Hi, this is my demonstration on algorithm visualization assignment for the CS6250 Advanced Computer Graphics and Visualization course. I have developed an interactive 3D visualization of Kruskal's algorithm using C++ in the AftrBurner engine. For graph construction, I implemented a recasting mechanism within the on-mouse down event handler to translate 2D screen space coordinates into 3D world position. I integrated IMQI interface to manage the process. Users can trigger vertex placement via the add vertex button or with the hotkey V button. Once the vertex placement mode is active, user can click on the anywhere in the world to add a vertex, and it will add vertex, and another I'm going prompt will be prompted. It contains the already drawn vertex vertices that can be used to create an edge with newly added vertex. So the vertex is added, and for another vertex placement, user can click add vertex v key, and once the vertex placement mode is active, user can click on the world to add vertex, and it will show the already drawn vertices list that can be checked to create an edge with the default weight between those two vertex will be the Euclidean distance between the two coordinates of the vertex, and the user can input manual weight if needed by in here. Let's say it's 50, and once the create edge is clicked, edge will be created. Because of the depth issue, the current vertices draw at the very deep position, and it's clipped by the camera near clipping plane and far clipping plane. If I have added visual settings that can be used to change the radius, the size of the vertex, and the edge line thickness. If I increase it, it becomes visible in here. Yeah, if I need to put precise coordinate on the vertex in the precise coordinate, I can use manual vertex input button here. I have in, if I click and add vertex at XYZ button, the vertex will be drawn at X these defined XYZ coordinate, and it will ask to have connect if you want to draw edge. Then after checking vertex list and create edges will be created as you can see in the screen. If I want to add more vertex, let's say, and click on add vertex and select the edges, the edge will be created like this. Let's add vertex and select an edges list. Edge will be drawn between all selected vertex. 25. I have added other methods like in the vertices list, it will display all the vertices, and I can change the coordinate of the vertices individually from here. Let's say I want it to be here. and move this coordinate. It will update the line as well. Let me decrease the thickness of the line and vertex. We can see that the cycle for Kruskal algorithm and has been formed. After completion of vertex addition, I can go to the run Kruskal's algorithm. I click on the run Kruskal's algorithm button. The Kruskal's algorithm will be activated, and the core algorithm is triggered by the run Kruskal's algorithm button, and it relies on the disjoint set union data structure. To optimize the performance, I have utilized path compression and union by rank method. Before the algorithm runs, all edges are sorted by weight to satisfy the greedy property required for finding the minimum spanning tree. Visually, the graph utilizes MGL primitive shape to render vertices as sphere and edges as cylinders so that it can become clearly visible. To properly align the connections between cylinder and spheres, I calculated an orthonormal basis for every edge to generate a specific rotation matrix that aligns the cylinder geometry between 2 points. Once the MST is computed, frame by frame animation loop modulates the ambient and specular screen coefficients to create a glowing visualization effect like this. And if I go all the way down in the I'm going panel, we can see the total minimum spanning tree weight is 189.83 and edges in the minimum spanning tree are 5, 1, 2, 3, 4, 5, and the edges are highlighted here. And I can add or remove edges if I want from here. And to remove vertices, I can go here and remove the vertex. And if I run Kruskal's algorithm again, this will display the updated minimum spanning tree. I can reset MST by clicking on this button. This will reset calculation and if added new vertices, edges will be created and again run Kruskal's algorithm. It will keep the minimum weight and minimum spanning tree by the highlighted edges. That's all for my algorithm visualization demonstration. Thank you for watching.